All right, so like I said, we're looking at 9A. And 9A is about functions. So this section is called functions. The building blocks of mathematical models. All right, I'm having to catch people and let them in while we're talking here. So it's the building blocks of mathematical models. All right, so first we'll talk about what a function actually is. So y'all, a function describes how a dependent variable changes with respect to one or more independent variables. So a function describes how a dependent variable changes with respect to one or more independent variables. Now, when there are only two variables, and that's basically what we'll mess with in here is just two variables max. So when there are only two variables, they are often summarized as an ordered pair. With the independent variable listed first. So y'all, ordered pair is what we call that. And y'all probably seen these when y'all did graphing with an X and a Y. Those are ordered pairs. So the ordered pair always has the independent variable first. Then you had your comma, and then the dependent variable. So y'all probably remember the independent variable was your X's. The dependent variable was those Y values. And I'm going to do an example in a little bit about a paycheck, and you'll see what I picked for my independent variable and my dependent variable. All right, let me write one in real quick. So basically, this means that the dependent variable is a function of the independent variable. So the dependent variable is a function of the independent variable. So if X is the independent variable, and Y is the dependent variable, we write the function as Y equals f of X. And y'all, that f of X is just function notation, letting me know I got a function. It gives the variable X, which is your independent variable, and Y is our dependent variable. So really that means that the Y values, they depend on what values for the independent variable that I put into my functions, okay? So I'm going to show you 3 basic ways to represent a function, and then we're going to do an example where I show you all 3 of those. So the 3 basic ways to represent a function. And y'all probably seen these somewhere in your life. First method, I can use a data table. Or simply just a table. So by table, y'all remember seeing this stuff? We had an X and a Y value with a little T chart, I called it. You picked your X values, you plug them into your equation, and you got your Y values. So the first method would be a data table. Second would be to draw a picture or graph. So draw a picture or graph. So examples of a graph. Now I'm not going to label it, but that's your X and Y axis. Y'all probably graphed on one of those in your lifetime. The X's would have numbers that go positive to the right, negative to the left. The Y values would be positive numbers going up, negative numbers going down. That's one form of a graph. Or if I didn't need all those negative numbers, you might see the graph like this, where they just use one of the corners of the graph for your data. So really depending on what kind of values you're putting into it determines what kind of graph I'm going to draw. And y'all, the third way would be write an equation or formula. Now, in our next class, when we do 9B, we'll be looking at formulas like Y equals mx plus b, which is the slope-intercept form of a line. So we'll play with them kind of formulas on the 9B. Today, I'm going to show you an example about paychecks, okay? And maybe sort of clarify these 3 different ways that I can represent my function. So this will be sort of like an example. So suppose a person makes $15 an hour. The job does not pay overtime. Okay, which means if they don't pay overtime, the max hours they can get is 40 hours in a week, okay? So we're gonna represent this as a function. Okay, so first of all, I'm going to come up with my equation that I can use for this function. So first of all, I got to figure out what's going to be my dependent variable and my independent variable. So we make 15 an hour. So what's going to determine my paychecks is how many hours I work for that week. So my independent variable is going to be the hours worked in a week. All right, y'all, let me let one in real quick. All righty. So like I said, the independent variable is going to be the hours you work. The dependent variable that's going to be the amount of your paycheck. Okay, so it's the dependent variable because the amount of that paycheck depends on how many hours you work. Now, my independent variable, hours worked, if I don't feel like working, then I'm not going to work as many hours certain days, okay? So the hours can change, but the amount of paycheck depends on how those hours are changing, okay? So that's what we mean by independent and dependent. So now if I wanted to make an equation for this, I'm going to let y be my dependent variable and x be my independent variable. So I would have something where y equals my $15 an hour, and I multiply that by the hours I worked. So x is the independent variable for my hours worked. The y is my dependent variable for the amount of pay. So that would be our equation. For our data table, I would have my x's and my y's. So I'm going to graph what I get on my data table. So for my data table, I'm going to go by tens from 0 to 40 to see what kind of amounts I will get on my data table. So what I'm going to do is I'm going to take these x values, plug them into this function up here, multiply by 15 and see what that gives me. So if I put 0 in for the x, 0 times 15 would be 0. So if I don't work any hours, I'm not getting any pay. All right, for 10 hours, I would put 10 in there. 10 times 15 would give us $150 gross paycheck. Put 20 in there. 20 times 15 would give us a $300 gross paycheck. All right, next I put in 30. 30 times 15 gives me $450 paycheck. And y'all finally, when you work 40 hours max, you'll get a maximum of $600 on your paycheck. Okay, so this is what you're talking about on a data table. Now, if you didn't have the formula, you can make a data table by actually using your paychecks and see what amounts you got for the different weeks for the hours you're working, okay? All right, so now let's do our graph. So to do my graph, I got to figure out what kind of x values I'm going to have. And later on, we're going to call that our domain. So the domain is going to be the x values. The range is going to be the y values. Notice, all my x's are positive and all my Y values are positive. So when I graph it, I don't need a full graph here. I can use the top right corner for what I need. So remember, the horizontal axis is the X, the vertical axis is the Y. So y'all, we didn't need to come down and go left on this one because we don't have no values that are negative in hours or negative in the pay, right? We want to work positive hours is all you can work, and positive pay hopefully is all you can get, okay? So this is going to be the hours worked. So you want to label your graphs, the hours worked, and they went from 0 to 40. So 0 starts in the little corner there, and I'm just going to go up by tens. So there would be 10, 20, 30, and 40. Now you could label this any way you want to. You could go by fives, 5, 10, 15, 20, all the way up to 40. Or you can even go by ones on this and go from 0 to 40 by ones on your scale, okay? Now the pay over here, this is the amount of pay on the side. The amount of pay. And it's basically going from 0 to 600. So here's my 0 down here. And then let's see, I'm going to go by 150, sort of like what we got here. So there's 150, 300, 450, 600. All right, so 0 hours, 0 pay. That first point, 0, 0 is going to be right here by those 2 zeros. Now remember, to plot the X's, you go left or right. If these are positive, you go right. If they're negative, we would have went left. Well, these are all positive, so we're going to go right from the origin, we call it. Now, the Y values can go up or down. If they're positive, you got to move up. If they were negative, we would move down. So watch what I do. So this point is 10, 150. So starting at 0, I go over to the 10, and then I go up to the 150 on the Y-axis. So if you was to draw a line down, it would hit the 10 on the X, and a horizontal line would cross it at the 150 on that Y-axis. All right, second point would be 2,300. So go over to 20 and then up to 300. And if y'all notice, this is going to make what we call a line. So it's going to be a linear function because the only thing that changes on it is the pay adds $15 for every hour. So here was 30, 450. So start at 30 and go up to 450. And then finally 40, 600, go over to 40 and up to that 600. So if you notice, it makes a nice little line going up through there, okay? But now I can use this to sort of estimate my pay for different hours. So look here, if I wanted to see my pay for 15 hours, I would come to about where 15 was on my graph and go up here to about the place where it's going to intersect that line. So if I go to the left, let's see, that should be around 200, 225. So you can sort of estimate different hours and the pay, okay? All right, so equation, table, graph. All three can represent that one function. All right, y'all, so officially, let's talk about the domain and range. So the domain is the set of values of the independent variable. that both make sense and are of interest for the function. So for my little problem up here, when I look at my domain would have been these X values, and they went from 0 to 40. Remember, I couldn't work anything over 40 hours. I did not get any overtime. So that's the only numbers that made sense for our domain. We don't want any negative numbers because you can't work negative time. And we didn't need any numbers past 40 because we couldn't work overtime, okay? So that's what they mean by it makes sense and it's of interest for this function that we're doing. So which means the range consists of the values of the dependent variable. That correspond to the values in the domain. So what they mean by that, since my domain had a minimum value of 0, and when I figured out my data table at 0, my dependent variable was 0 also. So it didn't make no sense for me to make my range negative because you can't get a negative paycheck. Now, my maximum hours was 40, which means my maximum pay would have been 600. So it does not make sense for me to make my range go past 600 because I won't be hitting them kind of values. So we want our range values to correspond to those values in that domain, okay? So on our problem up here, our range would have actually went from $0 to $600, okay? So that's the relationship between your independent and your dependent variables. So next we will officially see how I created and use those graphs for that function, okay? So let me see, new page. I'm gonna turn this over because it curved a little. So creating and using graphs of functions. So there's 4 steps we look at, okay? Step 1. Well, step 1 was to identify the independent and dependent variables of the function. So variables of the function. So we did that. We said, hey, our independent variable was going to be the hours we worked. Our dependent variables was going to be the amount of that paycheck. So we did step 1. Then we come to step 2, which is to identify the domain and range. So we did that. We said, hey, our hours could only go from 0 to 40 hours when we made our table. And we said our range could go from 0 pay all the way up to 600 pay. So we had to know that when we was making our graph, okay? You know, step 3 is actually make a graph using the data. Okay, so we did that. We made our graph, and we only had to make the top right corner of the graph because all of our values were positive. And then y'all, step 4, before accepting any predictions of the model, be sure to evaluate the data and assumptions from which the model was built. So they're sort of saying double check yourself. Does your graph fit your table? Does that table match the equation we're using? Okay. So before accepting any predictions of the model, so like I was going to predict number for 15 hours by using that line on that graph, okay? So that's what they're saying. Verify that this works. So be sure to evaluate the data and assumptions from which the model was built. Okay, so just sort of saying double check them answers. All right, y'all. So the last little thing I got to go over is I'm going to show y'all an actual graph, what it consists of, and what the different parts of an actual graph are, okay? So I'm going to draw a graph, a vertical line, and then I got a horizontal line. So this is a coordinate system. We're going to use an x-axis, and we have a y-axis. So the x's are numbered positive to the right of the y-axis. They're negative to the left. This center part on the graph is called the origin. And the coordinates of that origin are 0, 0. That's the 0 point on the x-axis. That's the 0 point on the y-axis. So like I said, the x is number right. So I'm going to go out about 5 on this. So it would go 1, 2, 3, 4, 5 to the right. It's going to go -1, -2, -3, -4, -5 to the left. Now the y value, where these lines intersect, is the 0 point on the y-axis also. Upwards, they become positive. So 1, 2, 3, 4, 5 up, and then down on the y-axis is negative. Okay. Notice it's broken into 4 sections. We call those quadrants. So this would be quadrant 1. To be in quadrant 1, both of your points are going to be positive. So that's why I only drew that section a while ago, because when I was doing the paycheck, my hours were going to be positive. My pay was going to be positive, okay? Now, the quadrants go counterclockwise. So this would be quadrant 2. To be in quadrant 2, the independent variable is negative. The dependent variable would be positive. So if your x is negative, the x's come left, and then they go up for those positive y values, okay? Down here is quadrant 3. For a point to be in quadrant 3, they both got to be negative. You know, they're not going to kill y'all with that kind of stuff. I'm just sort of showing you this so when we graph some points in a second, you sort of see where they need to land at, okay? All right, then finally, what's this? Quadrant 4. To be in quadrant 4, the x's are positive, the y's are negative. So when I plot points, if I know the signs, I know where they got to end up at, okay? So we're going to do a example plotting. I'm going to plot like 6 points for you. So let me let y'all write that down and we'll flip it and get going. Y'all got any questions at the moment? All right, so I'm not seeing nothing. So y'all, here we go. We're going to do an example, plotting points. We're going to plot. A will be 3, 1. And I'll put a letter by each point when I graph it. B will be -4, 2. C will be 1, -2. D will be -2, 0. E will be 0, 4. And then F will be -3, 0. All right, so let me draw a little graph real quick. So my x-axis and my y. Remember, these arrows go on forever in each direction, okay? So our points are pretty small, so I'm just going to go over 5. So there's 5. Then we'll do -5 to the left. We'll go up 5. And then down 5. All right, so there's our X and Y coordinate system. So now we're going to plot these 6 points. Now, when I plot points, I always start in the origin. I move left or right according to the X value, and then I'm going to move up or down according to the Y value. So remember, the X is left if negative, right if positive. The Y value is up if positive, down if negative. Okay, so the X's can only take me left or right, and then that Y value can only take me up or down. All right, y'all, so here we go. We're going to plot 3, 1. So starting in the origin, you're going to go 3 spaces to the right. 1, 2, 3. So you're sitting basically at the 3 on the x-axis, and then the y value was 1. So from 3 on the x-axis, we go up 1 and put our point. So that would be our A. So hopefully this is just mainly bringing back memories for y'all, okay? All right, -4, 2. Starting in the center, I go -4 to the left because it's negative. So 1, 2, 3, -4. From that -4, I'm going to go up 2. So let's see, I go up 1, up 2. That point will be our point B. All right, y'all, next is C. It is 1, -2. So starting at the origin, I go right 1, and then I go down 2. So that was C. Okay, so move that X and then up and down on that Y. So D was -2. What's that? -2, 0 for D. So -2, 0, starting in the center, go left 2. Now the Y value was 0, so that means you stay on the line. Anytime one of them numbers is a 0, you're going to be somewhere on that line, okay? So -2, 0 would be my D. And y'all, I think what we're going to do let's change this F because I don't want two of the same kind. So let's change F from -3, 0. Let's see, let's make that one -3, -1, okay? So change F from -3, 0 to -3, -1. All right, so I got A, B, C, D. Here comes E, 0, 4. So when the X values is 0, you stay right there in the center because it don't move left or right. And then you move up 4 for the Y value. So 1, 2, 3, 4 for the Y value, and that gives you point E. So anytime there's a point that's on the Y axis, when we're drawing lines, we're going to call that the Y intercept because that's where it crosses over that Y axis, okay? So we're not doing lines yet. That'll be next class. But anytime that line crosses over the Y axis, that's what y'all refer to as the Y intercept, okay? So it looks like I need a point down here, and that's F, right? -3, -1. So let me rewrite that so it looks better. So -3, -1. So I start in the center, go 3 left. So 1, 2, 3 left to -3, and then down 1 for the -1. That would be my last point by F. All right, so that's basically, they're going to have you draw, I think, 4 points on one of your homework problems. So they just want you to graph the 4 points and then pick out which picture looks like your graph, okay? So I got time. I'm going to do one more example for you. All right, so let me see. So I'm going to do one of our examples like you'll see in the homework.
Can you 1 second, please?
Yeah. I don't know if they were talking to me or someone else.
Yeah, I was asking, could you go back to the page?
On my page. The one I just did with the points.
Yes, that.
Yeah, okay.
Okay, you're good. Thanks.
Okay. All right, so y'all, on this example, they give me the speed, and they're putting it in miles per hour. Then they're going to give me what they call the stopping distance. And the stopping distance is going to be in feet. So they're looking at how fast the car is going and looking at its stopping distance that it takes it to stop once you start hitting on them brakes, okay? All right, so my speeds are going from 10 to 70, and they're going by tens. So 10, 20, 30, 40, 50, 60, and 70. Stopping distances go from 12 feet, 43 feet, 73 feet, 126 feet, 162, 231, and all the way to 316. So on these examples, they want you to identify the independent variable. And we're going to figure out the dependent variable. Then we'll look at the domain. Which one's going to be our domain and the minimum and maximum on it, and then our range. We'll look at which one's going to give us our range values and then their minimum and maximums, okay? Then we'll sort of do a little graph about it, and what we think the chart actually means. So remember, this first column is your X's. The second column is your Y values. X's are my independent variable. The Y's are my dependent variable. So going down through here, the independent variable is going to be the speed. The dependent variable is going to be the stopping distance. So when we label our graph, we got to remember the X's are going to be my speed on the bottom on the horizontal. The vertical axis is going to be my stopping distance.
I have a question.
Yeah.
If you come up to a problem and the order is switched, like it says stopping distance and then it says speed, would stopping distance then be your Y? Or I mean, then your X?
Well, if that stopping distance was any value and the speed depended on that, would be the way it would be a function.
Okay.
So you gotta, so your X's have to be the one that can be any amount. Those Y values have to depend on what those X values were.
Okay.
Okay.
Yeah.
And I'll sort of show you another example using an ordered pair, and y'all sort of figure out my domain and range. Okay. All right, so let's see the domain. So these values for my domain went from a minimum of 10 to a maximum of 70. So when I draw my graph, I'm going from 10 to 70. I don't need to go past 70 because that was the maximum speed they gave me on this. So they're obeying the speed laws apparently, okay? In our range went from what, 12 minimum to a maximum of 316. Yeah, I think on that one, it would be tricky trying to measure stopping distances and then figuring out what speed you would have to go to get to that stopping distance. That makes sense, Rachel?
It does. I was just wondering if they ever, if you ever get them out of order, like if they ever try to trip you up like that, you know what I
Oh,
mean?
no, they're going to try to trick you up on these pictures I'm about to show you.
Okay.
Yeah, they're going to switch the axes. They're going to try to switch them numbers up on you. They're going to try to fool you. So you just got to remember when we label it, this column is always going to be that x-axis going across, and then the second column is always going to be that vertical.
Okay.
All right, so if I was going to draw this graph, let me make my y and my x. So now, important on this label down here, since this is my x, it's got to be my speeds down here. And my speeds are going by 10s all the way to 70. So if the center is 0, that'll be 10, 20, 30, 40, 50, 60, and 70. So that's basically all I had to go for my domain. Now my range is looking what, from 2 to 316. So I think they went by, let me see what they went by. They went by 50s on that. So they had 50, 100, 150, 200, 250, 300, and then they had 350. That would be 400, but they only needed to go to 350 on that. So that was their highest value, okay? And basically, they didn't list zero, nothing but the 0 down here. And then they put a 0 there. All right, so our graph for 10 miles per hour speed, we had a 12-foot stopping distance. So here's 10. So 12 is just going to be a little bit above that line. At 20, we had 43. Whoops, hold on. When I say, oh, wrong line, y'all. Woo, the 12 should be way down here. Because that's 50, right? So 12 has to be down here. So exit that one out. Now at 20, I was at 43, so it's still above, still sort of below that, because remember, that's 50. 30, I was at 73, so I'm above it finally, about right in here. At 40, we're at 126. So remember, that's 150, so 126 is about in the center. At 50, we had 162. So let's see, there's 150, so 162 be a little above that. Well, it's tricky when you don't have a lot of scales on these graphs, you know it. 60, they was at 231. So here's 230, 250. So 231, a little bit in the center there. And then finally at 70, I was at 316. So here's 300. So 316 would just be a little bit above that. But you'll sort of notice, you sort of get a curvy little line going up. So let me show you what they're doing to yield mapping. If you notice, the faster you drive, the longer it's going to take you to come to a stop when you're braking, okay? And we would expect that, right? Now remember, this could change depending on how heavy these cars are. They might have more stopping distance. Lighter cars might have a smaller. So not knowing what vehicle they're doing, this would be the graph for it. So look here what they do to you. This one's a straight line, which is not right because our values weren't going up the same amount each time. For that to be a straight line, this would have had to been 12, 24, 36. It would have had to went up the same amounts. So then over here, I actually picked this one because notice on the bottom was the speed like we had. On the side was the stopping distance. And our graph sort of went along and curved up. This one, they had the marking right, the speed and the distance. But y'all look at this. Their graph, their Y values are backwards. When we was at 10, we should have been here at 12, not up here in the 300s, okay? So they labeled those Y values backwards. This one looks right, looks like the same graph I had, but notice the difference. They put the distances that you stop on the bottom axis, and then they put the speed on the vertical axis. They put them backwards from each other, okay? So Rachel, that's what you got to watch for on them. They're going to try to reverse those names on there just to throw you off a little bit, okay?
Okay.
All righty, y'all. I'm going to show you one more thing here, and then we'll be done. This one is the weight of a car. And the average gas mileage. So we want to find our independent variable. And our dependent variable. And then we'll sort of look at what they're hitting us with on our domain range. So the independent variable, like we said, is these x's, and then the dependent will be the y values. So what can change on this is the weight of the car. Now, the gas mileage depends on the weight of the car for these models, okay? So if your car is heavier, it's going to be harder to move, which means it's going to work harder, which means as the heavier you get on that car, the less gas mileage you're going to get, right? So our independent variable is going to be the weight of the car. And they're really wanting you to get used to seeing ordered pairs and graphs to sort of recognize them, okay? And that little table I just showed you. All right, so that means my dependent variable has to be my average gas mileage. So now, when they was giving y'all the domain on this, they give you two choices for the domain. Now, they're going to give you two wrong ones also. So the two ones that were definitely wrong were the ones that said the domain is the average gas mileage. Well, that's not right, because our domain is the independent variable, which is talking about the weight of the cars. So for the two choices on the weight of the cars, would you pick the domain is the typical weights of all cars, or 100 pounds to 800 pounds? Or would you pick the domain is the typical weights of cars, or 1,000 pounds to 8,000 pounds? So which one sounds more reasonable?
1,000 to 8,000.
So yeah, that's going to be the 1,000 to the 8,000 pounds. All right, and they sort of do that on your range. So the range we said was the average gas mileage. So they got two wrong ones that say the range is the typical weights of the cars. Well, we know that's wrong because that's our domain. So of the two right ones for the range is all average gas mileages of cars of various weights, or 5 miles a gallon to 300 miles a gallon. The second choice, the range is all average gas mileages of cars of various weights, or 15 miles a gallon to 35 miles a gallon. So what would y'all figure for this one?
The 15 miles per gallon.
There you go. So
To
15
30.
to 35. Now we know we got cars that can beat that 35, but for their example, they just wanted to sort of ballpark it a little bit with you. All right, so they have the graph. We said our independent variable was the weight in pounds. The dependent variable was the what was that? The gas mileage. So they're using the M for mileage, and that's in miles per gallon. So remember, the weight we said could go from 1,000 to 8,000. So they started us down here at 1,000, and looks like they're going by 1,000 each time. So right here would be my 8,000. The stopping, the miles per gallon, we said went from what, 15 to 35. So they even had the 0 for that. And then looks like they're going up by 5s on that. So 5, 10, 15, 20, 25, 30, 35. And on that, they're showing that they had points that went downhill. They didn't want you to figure out these points, but they were showing y'all how this would go downhill, sort of, and it makes a little curve coming down through there, okay? So I'm going to show you the graphs they have so that you'll be able to see what you're doing. Now, the first graph looks good because the heavier these cars are going to the right, the less that gas mileage is going to be. Okay. But notice, they got the miles down here and the weight of the car over there. So that's another one where they got them backwards, okay? This one, they had the weight on the bottom like we needed, from 1,000 to 8,000. They had to stop the miles per gallon where we needed it on the y-axis. And it went from 0 to 35 like we picked up here. These two have the wrong domains down there. This one went from 100 to 800 for the weights of the cars. Well, no, they even had it wrong on the miles per gallon on this one. So they had miles per gallon down here where it should have been on the side and the weight should have been down here. And then on this one, they had the weight right and the miles per gallon right, but they had the wrong scale on that domain, okay? So you want to find one that matches your labels and your domain values, okay? And then we said the graph is valid model of the function because gas mileage of a car decreases as the weight increases. So that's why this graph is sort of going downhill because it's decreasing. The one I did want to go with the stopping distance, the faster you went, it was increasing the amount of stopping distance, okay? All right, y'all, so next class, we're going to learn about slope and linear lines and some fun stuff like that, okay? So what I'll do, I'm going to go, I'll save this recording and send y'all a link in about an hour or so, once I get it up into the YouTube, okay? Now, here's another thing. If you're having trouble using Excel for your project, you can use other methods, but I wanted to tell you, if you're using Excel, I sent a file this morning on how you can do the project on Excel if you just know all your data points. So on that project, I showed you how to find the mean, the median, the standard deviation, how I figured out the lower quartile, upper quartile, and all that fun stuff. And then how I made a little pie chart on it. So I think the video is only like 10 or 15 minutes that I sent this morning. But it don't take long once you got your data in that, okay? So hopefully y'all can do the project by Sunday night. If not, definitely try to get it done during the Thanksgiving break. So we got one more class Thursday, and then y'all are out for a week. We'll be done with all the material for this class on Thursday. 9B is the last section. We'll take our break. When we come back from break, we're going to review for your second test. That's over chapter 8 and 9. And then I'm just going to start reviewing for that final exam on the last class, okay? All righty, so let me stop the recording.